the sleepy story of noticing our solar system, from ancient skies to modern science. Let the room settle into a gentle quiet, a calm stillness like the hush of a night sky waiting to reveal its secrets. Imagine yourself lying back, eyes closed, feeling the soft rhythm of your breathing as you begin a slow journey through time, tracing the human fascination with the sky above and the intricate dance of the celestial bodies we now call our solar system. Long before telescopes or even writing, humans raised their eyes to the night sky. The earliest observers were our ancestors, tracing the wandering points of light across the heavens. They noticed the moon changing shape, brightening and dimming in a slow, soothing rhythm. They watched the sun rise and fall with unfailing regularity, and they saw the stars wheel overhead, forming patterns that shifted gently with the seasons. These observations were not hurried. They were patient, practiced, quiet acts of noticing. In those early times, the sun, the moon, and the bright stars that moved differently from the rest were seen as gods or spirits, guiding the cycles of life on Earth. In the ancient Near East, around 5,000 years ago, civilizations began recording these movements. The Babylonians, with their clay tablets and meticulous records, marked the paths of the planets: Mercury, Venus, Mars, Jupiter, and Saturn, though they did not yet know these bodies as planets in the way we do today. Their observations were intertwined with astrology, a kind of storytelling of the heavens, where the movements of the planets were thought to influence life on Earth. Still, behind the rituals and predictions lay careful watching, counting, and recording, a steady accumulation of knowledge that would echo across millennia. Far across the Mediterranean, the ancient Greeks began to ponder the movements of these celestial wanderers. Figures like Pythagoras, nearly 2,500 years ago, imagined a cosmos ordered and harmonious, a vast sphere in which the stars and planets moved in perfect circles. Later, Plato and Aristotle refined these ideas, developing a view of the cosmos that placed the Earth at the center, unmoving, with the sun, moon, and planets rotating in perfect crystalline spheres around it. This geocentric model, comforting in its symmetry, would dominate human thought for centuries. Slowly, quietly, careful observers like Hipparchus began measuring the stars and planets with more precision. He noticed slight variations in the motion of the moon and calculated the length of the year with impressive accuracy. These measurements were gentle steps forward, tiny yet important, as humans began to perceive that the universe had rules, patterns, and rhythms that could be understood, even if only a little at a time. Centuries later, Ptolemy compiled the observations of his predecessors into the Almagest, a grand and careful record of the known heavens. The Ptolemaic system, with its circles upon circles, epicycles, and deferents, explained the apparent retrograde motion of the planets. Though complex, it was elegant in its attempt to describe the motions of the wandering stars in a calm and orderly way. People would use these ideas to guide calendars, to navigate the seas, and to predict celestial events, all with a serene confidence that the cosmos was knowable, even if it remained distant. The gentle tide of time carried humanity into the Renaissance, a period of renewed curiosity and subtle revolution. In the 16th century, a quiet Polish astronomer named Nicolaus Copernicus proposed a profound shift in perspective. Instead of the Earth at the center, he suggested that the sun rested at the heart of the system, and that the planets, including Earth, moved around it. His ideas were careful, almost cautious, published only at the end of his life, yet they set the stage for centuries of exploration and discovery. The heliocentric model did not immediately overthrow the old ways, but it whispered a new understanding to those who were patient enough to listen. Soon after, Johannes Kepler, a German mathematician, began to study the detailed observations of Tycho Brahe. Kepler noticed that planets did not move in perfect circles, as the ancients had imagined, but in gentle ellipses, moving faster when they were closer to the sun and slower when farther away. His three laws of planetary motion described these movements with precision, revealing the natural rhythm of the solar system in a way that was almost musical. Slowly, the veil of mystery lifted, and the quiet patterns of the planets became ever clearer. Galileo Galilei, looking through a telescope in the early 17th century, was the first to see the moons of Jupiter, the phases of Venus, and the rugged surface of our own moon. His discoveries were soft yet firm. The heavens were not perfect spheres, unchanging and divine, but dynamic, textured, and full of wonder. His observations, gently chronicled, challenged centuries of assumptions and opened the door to the modern understanding of our cosmic neighborhood. Isaac Newton, in his calm and contemplative way, then synthesized these ideas into the law of universal gravitation. With a quiet certainty, he showed that the same force that made an apple fall to the ground guided the planets in their majestic orbits around the sun. The solar system, once imagined as a set of mystical circles, was now revealed as a dynamic system governed by mathematical principles, unrushed, predictable, and comprehensible to those who took the time to observe, calculate, and understand. Through the 18th and 19th centuries, astronomers continued to watch, catalog, and measure. William Herschel discovered Uranus, adding a distant note to the familiar harmony of planets. Later, Neptune and, eventually, Pluto, though Pluto's status would change in later years, were noticed through careful observation and patient calculation. Each discovery was a whisper from the cosmos, a quiet reminder that there was always more to learn if one simply observed with patience. In the 20th century, the advent of photography, spectroscopy, and later, spaceflight, transformed our understanding of the solar system. Telescopes could capture faint light from distant objects, revealing the colors and compositions of planets, moons, and asteroids. Robotic spacecraft carried instruments directly to the planets, sending back images of icy moons, volcanic landscapes, and swirling storms. Humans no longer only observed from afar. They reached out, touching the edges of the solar system with probes, orbiters, and landers, each mission a gentle nudge expanding our knowledge. Missions like Voyager, sent on slow and steady paths outward in the 1970s, have traveled farther than anyone could have dreamed, their golden records carrying greetings from Earth into the silent depths. Each passing year, they send data back to a tiny dot of life in the universe, whispering the story of our solar system's outer reaches. Closer to home, rovers on Mars crawl slowly across dusty plains, studying rocks, analyzing soil, and searching for signs of past water, each movement deliberate and careful, a testament to patience in exploration. As the 21st century unfolded, we learned more about the small bodies of the solar system, asteroids, comets, and dwarf planets, mapping their orbits and composition. Satellites orbiting the sun, like SOHO and STEREO, watch solar activity with patient attention, revealing the cycles of solar wind, flares, and coronal mass ejections. New telescopes, such as the James Webb Space Telescope, peer into the distant reaches of our system and beyond, capturing infrared light and revealing details that would have seemed magical to the astronomers of old. Today, our understanding of the solar system is precise yet still expanding. We know the planets, their moons, and their orbits. We can describe the atmospheres of Venus, Mars, and the giant gas planets. We track the countless asteroids and comets that travel between the planets. We even consider the possibility of life elsewhere in our solar neighborhood, pondering quietly the potential for microbial life beneath the icy crusts of moons like Europa and Enceladus. And yet, despite all we have learned, The night sky remains a serene, eternal presence above us, waiting for the patient observer to notice the subtle dances of planets and stars, just as humans have done for thousands of years. In this slow unfolding, the story of noticing our solar system is also a story of patience, of careful attention, of gradual understanding. From the first humans who saw the moon waxing and waning, to the ancient astronomers who drew circles on clay tablets, to the modern scientists sending spacecraft to distant planets, each step has been deliberate, unhurried, and full of quiet awe. And now, as your eyes grow heavier and your mind drifts gently along the orbits of planets and moons, let yourself feel the rhythm of the cosmos. The solar system spins, slow and steady. The Earth turns in space, the moon follows its path, and the planets trace their elliptical orbits around the sun. All is quiet, all is calm, and all is patiently observed as it has always been. Soon you may find yourself drifting into sleep, dreaming of icy rings, fiery suns, and the gentle sway of the planets in their timeless dance. Remember that the story of noticing our solar system is ongoing. Every telescope, every spacecraft, every quiet observation adds a new verse to the endless, slow, beautiful poem of the cosmos. Sleep now as the planets spin gently, the sun warms the distant worlds, and the universe, vast and quiet, whispers its secrets to those who take the time to notice.